So our today's topic there is EMF or cell potential of a cell. That what is the EMF or what is the cell potential of cell. So full form of EMF is the electromotive force and the potential means power. So electromotive force or cell potential of the cell, that what power is present in the cell, or what is the power of the cell. So basically the electrochemical cell consists of two half cells. I had told you in the earlier lecture that there are in electrochemical cell there are two half cells. One is oxidation cell and other is the reduction cell, and the two electrodes in these half cells have different reduction potentials. So in what was happening in the electrochemical cell, there was two half cells, and when we connected these with the help of wire and used the salt bridge, there was a flow of current. So what is the reason, what was the reason of flow of current? I told you there, I told you that the reason was that one redox reaction, that zinc was undergoing oxidation whereas copper was undergoing reduction. So zinc was losing electrons and copper was gaining electrons. So what is the basic chemistry behind this? This is the redox reaction that was taking place between the zinc and copper electrode. That is, one is oxidation electrode and other was the reduction electrode. So basically they have different tendency to lose or gain the electron, those electrodes. So the so suppose there are two electrodes, that is A and B, and if we will compare their reduction potential or reducing power, that suppose that the reduction potential of B is higher than the reduction potential of A. It means B have higher tendency to gain the electron as compared to B has higher tendency to gain the electron as compared to the A electrode. So it means the B, when we will connect A and B as electrodes in a electrochemical cell, B will gain electron due to higher potential of gaining electron. And as I told you that redox reaction always goes side by side. It means when reduction is taking place at a particular metal, there must be somewhere oxidation to connected to it. So here the A electrode will lose the electron. So automatically A electrode will undergo oxidation and B will undergo reduction due to higher reduction potential of it as compared to A. So the electrode having higher reduction potential will have higher tendency to gain the electron, whereas the electrode having low reduction potential will have lesser tendency to gain electron. Rather, it loses electrons. As a result of this potential difference, there is a flow of electron from the electrode with a low reduction potential to the electrode with the higher reduction potential. So in the electrochemical cell, I told you that there was a flow of electron from the zinc to the copper. There was the flow of electrons due to low reduction potential of zinc as compared to copper. The difference between the electrode potential of two electrodes constituting an electrochemical cell is known as the electromotive force. So the difference between the electrode potential of two electrodes, difference between the electrode potential of two electrodes constituting an electrochemical cell is called electromotive force or EMF of the cell potential of a cell. So this is basically the difference between the electrode potential of two electrodes. So thus this acts as a driving force for the cell reaction. The potential difference is expressed in the volts. So therefore the cell potential or EMF arises from the difference in the tendency of two ions to get reduced. So particularly if you want to know the EMF of a cell, so how you will come to know the EMF of a cell? It means the reduction potential of cathode minus reduction potential of anode. So it is the basically difference between the reduction potential of two electrodes, that is reduction potential of, obviously the reduction always goes on the cathode because it has higher power to gain the electrons. So reduction potential of the, when we will make a electrochemical cell, we will put a system in the lab to set up a electrochemical cell. We will make two beakers, and suppose you don't know the which of the electrode, which metal have follow, which metal is the cathode or which metal is the anode. You have been simply given the two electrodes and asked to put a electrochemical cell. You will put these two electrodes in two separate beakers and set up a electrochemical cell, and when you will connect the circuit, you will see where the reduction is taking place and where the oxidation is taking place. After identifying the reduction and oxidation on respective electrodes, you will categorize them cathode and anode. And it's by convention that when you draw a electrochemical cell in a notebook, or you graphically represent an electrochemical cell, you always represent the oxidizing electrode on the left hand side, whereas the reduction electrode is always represented on the right hand side. And when you will set up practically in the lab or electrochemical cell, after identifying that on which electrode reduction or oxidation going on, you will notify them as cathode or anode. In the reduction electrode will be called as cathode, whereas the oxidation electrode will be called as anode. So here you will if you want to know the EMF, you will identify the reduction potential of cathode and then subtract it from and then reduction potential of anode, and take the difference of these two to show the EMF of the cell. So E of the cell EMF, that is E of electrode potential of cathode minus electrode potential of anode. So in the representation of the electrochemical cell as a convention, cathode is written on the right hand side and anode on the left hand side. Therefore EMF of cell may be written as E right minus E left. So thus EMF of a cell may be defined as the potential difference between the two electrodes of the cell when either no or negligible current is allowed to flow in the circuit. So measurement of the EMF is done by the, so next is the measurement of EMF. Always keep this equation in your mind. It will come again and again and help you to solve many of the numerical problem which will come in the exam. So there is the reduction potential of cathode minus reduction potential of the anode. So the measurement of EMF, the EMF of the cell can be measured by connecting the two electrodes to a voltmeter and taking the reading directly. But this method has following objections. The first is the voltmeter draws some current from the cell, so the EMF of the cell will change. Second, due to the appreciable flow of current, a part of EMF is used to overcome the internal resistance of the cell. Third, both these objections can be overcome by the potentiometric method of measurement of EMF of the cell. This method is based on the Pong-Droff compensation principle. So this method is given in the book, you can see it from there. And this was the EMF or the cell potential of the cell. So next are the reversible and irreversible cells. So to establish the thermodynamical reaction between the energy of a chemical reaction taking place in an electrochemical or galvanic cell and the electrical energy produced by it, the cell must work in the thermodynamically reversible manner. So a cell is said to be reversible when it is sending off infinitesimally small current, so that the cell reaction always remain virtually in a state of the equilibrium. So a cell is said to operate reversibly when it is sending out infinitesimally small current, so that the cell reaction always remain virtually in a state of the equilibrium. So they are saying a cell is said to be a reversible cell when it is sending off a infinitesimally small current, so that the cell reaction always remain virtually in a state of the equilibrium. So if it is connected to an outside source of EMF, exactly, so reversible cell must satisfy the following condition. So if it is connected to an outside source of EMF exactly equal to that of the cell and acting in the opposite direction, then no chemical reaction should occur within the cell and no current is given out by the cell. Second condition is when the opposing EMF is infinitesimally smaller than the EMF of the cell. So opposing EMF is infinitesimally smaller than the EMF of the cell. So this is the condition for the reversibility of the cell. Third is the when external or opposing EMF is infinitesimally greater than that of the cell and extremely small current should flow through the cell in opposite direction, and the small amount of the chemical reaction also occur in the reverse direction. So it means that opposing EMF is infinitely smaller, infinitesimally greater than the EMF of the cell. And first condition was that EMF of source is equal to that of the cell and acting in the opposite direction. It means EMF of cell is equal to the EMF of source. So all electrochemical cells are reversible cells. So these are the reversible cells, and opposite to it are the irreversible cells. So you may make a comparison between the reversible and irreversible cell. So there is the small difference between the EMF of the reversible cell, that is either between the opposing EMF and EMF of the cell, either between the EMF or EMF of the cell is equal to is exactly equal to the EMF of the source. So these are the basics of the reversible and irreversible cell.